Okay, in the last class, we discussed about the mean value Rolle's theorem. In the last class, we discussed about the Rolle's theorem. First, we have to recall what is the Rolle's theorem. Okay, what is the Rolle's theorem? The given function f is differentiable on closed interval a comma b. The given function f is defined on closed interval a comma b. The condition 1, f is continuous on closed interval a comma b, and f is differentiable on open interval a comma b. And the third condition, f of a equals to f of b. Then there exists an element c in the open interval a comma b such that f dash of c equals to 0. F dash of c equals to 0 means the slope of the function at c equals to 0. That means the tangent at a point C, one tangent will exist which is parallel to x-axis. This is called the Rolle's theorem. Once again, I am telling you, in the Rolle's theorem, what is the meaning of Rolle's theorem? What is the graphical representation of the Rolle's theorem means? There exists C in the open interval a comma b such that f dash of c equals to 0. F dash of c equals to 0 means there exists a tangent which is parallel to x-axis. That is the Rolle's theorem. In this class, we have to discuss the Lagrange's mean value theorem. The Lagrange's mean value theorem. What is the Lagrange's mean value theorem here? The given function f of x is defined on closed interval a comma b. Suppose y equals to f of x is continuous on closed interval a comma b. This is the first condition. Suppose y equals to f of x is continuous on closed interval a comma b and differentiable on the open interval a comma b. There is a two conditions here. This is the condition 1 is continuous. The condition 1 is continuous on closed interval ab. The second condition, what is the second condition? Differentiable on open interval a comma b. This is the condition 1. This is the condition 2. But in the Rolle's theorem, there is a total 3 conditions. Condition 1 is continuous on closed interval AB and differentiable on open interval AB. And in the Rolle's theorem, there is a third condition. What is the third condition? F of A equals to F of B. Here, there is no third condition in the Lagrange's mean value theorem. Then there exists at least one point C in open interval a comma b at which f dash of c equals to, here f dash of c equals to f of b minus f of a by b minus a. But in the Rolle's theorem, there exists same point c belongs to open interval a comma b such that f dash of c equals to 0. This is the Rolle's theorem. Okay, what is the difference between the mean value theorem and Rolle's theorem? In the mean value theorem, there is only two conditions. One is continuous on closed interval AB. Another one is differentiable on open interval a comma b. There is only two conditions. But in the Rolle's theorem, there is an extra condition. The third condition is f of a equals to f of b. Then there exists a point in the open interval a comma b. Then there exists a point c in the open interval a comma b such that f dash of c equals to f of b minus f of a by b minus a. This is the Lagrange's theorem. But the same concept in the Rolle's theorem, f dash of c equals to 0. This is the statement of the Rolle's theorem. Now we have to prove this Rolle's theorem. How to prove this Rolle's theorem? See the proof of the Rolle's theorem. We picture the graph of f and draw a line through the point capital A of a comma f of a and capital B comma f of b. That means here a is the one point and b is the one point in the given curve. See, this is the x-axis. On the x-axis, there is a 2 points a comma b. Suppose this is the a comma b, then this point is called capital A. Capital A means a comma f of a. And there is a capital B. Capital B means here b comma f of b. there is a 2 points. One is capital A comma f of A. Another one is capital B of B comma f of B. There is a 2 points. If you join these 2 points, you will get a one line. The line AB or line segment AB. This line segment, this is the curve. This is the greens. You can see the green line or blue line. This is the given function. This blue line is the y equals to f of x function. Already they clearly written here y equals to f of x function is the blue line. And AB is the one of the line joined these 2 points. Then the first condition f is continuous on the closed interval a comma b. The f is continuous on closed interval a comma b means there is a continuous curve without any splittings between a and b. That is the condition 1. The condition 2 is f is differentiable on open interval a comma b means there exists a tangent everywhere between a and b. There exists a unique tangent between on the curve. On the curve, there exists a unique tangent at any point between a and b. That is the point number 2. Now, see, suppose for example, already you know the formula for slope. What is the formula for slope? Already you know. The slope already in intermediate already you studied. The slope m equals to y2 minus y1 by x2 minus and x1. Here y1 means f of a. y2 means f of b. Here x1 means a, y1 means b. So if you substitute this is x1 y1 and x2 y2 in this formula, this is a means x1 y1, this is the x1, this is the y1. Here this is x2, this is the y2. If you substitute these values in this formula, slope m equals to y2 minus y1 by x2 minus x1, you will get this value slope equals to f of b minus f of a by b minus a. This is the equation. Once again, I will tell you, this is the one of the given curve between a and b. At the point at a, I am taking a point capital A. This is a comma f of a. It is denoted by x1 comma y1. I am taking the point b at b, that is b comma f of b. Here x1 comma x2, x2 comma y2. So if you join these 2 points a and b, you will get a one line segment or a line. The slope of this line is equals to m equals to y2 minus y1 by x2 minus x1. If you substitute the corresponding values here, you will get slope equals to f of b minus f of a by b minus a. Okay, now come to the next one. So see this point. Here there is a one point a, that is capital A of a comma f of a. There is a one point b on the x-axis. This is b of b comma f of b. Here this is the one straight line. Here this blue line is the blue curve is the y equals to f of x, or it is the given curve. Now I am define a function g. A function. Here I am defining a new function g. What is the function g? G of x equals to f of a plus f of b minus f of a by b minus a into x minus a. This is the one of the new function. Here I defined this function g equals to f of a plus f of b minus f of a by b minus a into x minus a. One thing, this is the x minus a. This is the linear function. Linear. Why? Because here the power is 1. X power is 1. Therefore, it is linear. And also it is in the numerator. That's why this is the linear function. The linear function are polynomial function. Simply, it is called a polynomial also. It is also polynomial. Already I told to you, polynomial function is always differentiable and also continuous on any interval. Therefore, G is here, G is differentiable and also continuous. G is differentiable. G is differentiable and continuous. G is differentiable and continuous on any interval. Here our interval is a comma b. On the a comma b is also the function is differentiable. Here I am taking open interval. It is the open interval. It is continuous and also differentiable. So leave it. Now come to the next one. The vertical difference between the graph of f and g at x is vertical difference. What is the meaning of vertical difference here? Vertical difference means I will show you here. This is suppose for example, this is the f of x one function. Suppose if we take one more function here, suppose this is the another function. This is some g of x. This is the y equals to g of x. Suppose this is the f of x equals to g of x. So these are the two functions. If vertical difference means if you take a one vertical line like this, if you take a one vertical line here, this is the value of suppose for example, this is the value of suppose a comma suppose not a, this is some l comma f of l. This is some at the same time here also l. Why? Because this is the point l. L comma f of l. This is the l comma sorry. This is g of l. L comma g of l, this is L comma f of L. So here the vertical difference means the difference between the f of L minus g of L. This is called the vertical difference. Suppose for example, here I am taking the one of the line. This is some x. If you take this is some x, here this point is x comma f of x. This is the point of, this is also x comma, this is g of x. This is the f of x. Here the vertical difference means f of x minus g of x. This vertical difference I will denote it by capital H of x. That is the vertical difference. Vertical difference means first take a one vertical line or a perpendicular line at a point x or at a point L on the x-axis. If you take a point x on the x-axis, if you draw the one perpendicular line, this is the perpendicular line. If you draw the one perpendicular line, at this point you will get x comma g of x, and at this point you will get the x comma f of x. X comma f of x. This point is x comma f of x. So vertical difference means the difference between the only y variables. Y variables means f of x minus g of x is called the vertical difference. This vertical difference I denoted by small h of x. Now check it. So here I am taking the vertical difference. Already I told you vertical difference h of x equals to f of x minus g of x. F of x means given function. We don't know here the given function. Minus g of x means already you know g of x already we defined here. F of a plus f of b minus f of a by b minus a into x minus a. This is the polynomial function. This g is also differentiable and also continuous on open interval a comma b. Therefore, substitute this g value here in front of g. There is a minus is there. So therefore, minus into plus minus f of a minus into plus minus f of b minus f of a by b minus a. Here this minus is belongs to entire this term into this one. But if you here we have to discuss one point. What is that? Here this function already we discussed. This is the g. G is also continuous on closure interval ab. F of x is also different continuous on closure interval ab. Therefore, f of x minus g of x. That means h of x is also continuous on closure interval ab. Continuous on closure interval AB. Why? Because f is continuous, g is continuous. Similarly, f is differentiable on open interval AB and g is also differentiable on open interval AB. Therefore, f of x minus g of x. That means h of x also differentiable on open interval AB. So therefore, finally, here we have to understand one important concept. What is that? Here h is continuous on closure interval AB and h is differentiable on open interval AB. This is the very, very important to you. So here h of x means this is the h of x function. This h of x function is continuous on closure interval AB and differentiable on open interval AB. That is, see here, once again I written the same concept here. What is that? The function h satisfies the hypothesis of the Rolle's theorem on closure interval a comma b. What is the meaning of hypothesis of the Rolle's theorem? Continuous on closure interval a b. Already I told to you. Therefore, it is continuous on closure interval a b and differentiable on open interval a b because both f and g are continuous on closure interval a b and differentiable on open interval a b. Therefore, the function h means the difference of f and g is continuous on closure interval AB and differentiable on open interval AB. That is therefore H satisfies the two conditions. What are the two conditions? One is continuous on closure interval AB. Another one is differentiable on open interval AB. Two conditions satisfied. This is the condition 1. This is the condition 2. But in the Rolle's theorem, there is a third condition is there. What is the third condition? H of A equals to H of B. Why the H of A equals to H of B? Once see here. See here, H of A equals to H of B. It is clear. Why? Because I will tell you, this is the H of X. Okay, I will tell you here. You can see H of A. H of A means, you can see H of A equals to, if you substitute, this is the H. If you substitute A here, F of A minus F of A minus into F of B minus F of A by B minus A into here A minus A. A minus A means this is 0, this entire term is 0. F of A is cancelled. This is 0. This value is 0. Therefore, you will get H of A equals to 0. Similarly, see H of B. H of B means F of B minus F of A. At the place of X, we have to substitute. At the place of X, we have to substitute B. Then minus integration of F of B minus F of A by B minus A into B minus A. B minus A. Here, this B minus A cancel. Then finally, you will get F of B minus F of A minus bracket F of B minus F of A. Therefore, this F of B minus F of A, F of B minus F of A will cancel. Finally, you will get 0. Therefore, H of A is 0 and H of B is also 0. Therefore, here they clearly written H of A and H of B both are equal. This is the third condition. This is the third condition of the Rolle's theorem. Once again, I am telling you Rolle's theorem. Rolle's theorem, according to Rolle's theorem, H, the given function H is continuous on, according to Rolle's theorem, the function H is continuous on closed interval AB, differentiable on open interval AB, and third condition H of A equals to H of B. Therefore, H satisfies the Rolle's theorem. Therefore, by the Rolle's theorem, by Rolle's theorem, from the Rolle's theorem, what can we write? Therefore, by Rolle's theorem, there exists C belongs to A comma B. By Rolle's theorem, there exists C belongs to open interval A comma B such that H dash of C equals to 0. H dash of C equals to 0 at some point C belongs to open interval A comma B. This is the Rolle's theorem. By Rolle's theorem, therefore F dash of C equals to 0 at some point C should be between A and B. This is the point we want for the equation 1 in the theorem. So that means here clearly we know that H dash of C equals to 0 by Rolle's theorem. By Rolle's theorem. This is the Rolle's theorem. Okay, H dash of C equals to 0. But what is H? H equals to, already you know, see what is H? H of X equals to, what is the given function H of X? F of X minus, see what I told to you about the H of X. See, this is the H of X. F of X minus F of A minus bracket F of B minus F of A by B minus A into X minus A. This is the H of X. So now we can take H of X such that this is the H of X equals to F of B minus F of A, F of B minus F of A minus bracket F of B minus F of A by B minus A into X minus A. This is the H of X. If you differentiate on both sides, with respect to X, then H of X differentiation is H dash of X. F of X differentiation is F dash of X. Here, F of A is the constant value. Why? Because there is no X here. Therefore, F of A is the constant. Its derivative is 0. So, this derivative is 0. This derivative is 0. This derivative is 0. Why? Because F of A, there is no X here. Its derivative is 0. Leave it. F of X differentiation is F dash. F of A differentiation is 0. Minus what is in this bracket, it is entirely, it is constant. Why? Because there is no X here. Therefore, it is entirely constant. So, constant f of b minus f of a by b minus a into here x differentiation is 1, a differentiation is 0. Therefore, 1 into something, this one. Therefore, h dash of x equals to f dash of x minus f of b minus f of a by b minus a. But already you know, if you substitute x equals to c, here, if you substitute x equals to c here, at the place of x, if you substitute at the place of x, if you substitute 0, sorry, c, then you will get h dash of c equals to f or f dash of c minus f of b minus f of a by b minus a. But what we know, according to Rolle's theorem, in the previous slide, I already told to you, according to Rolle's theorem, h dash of c equals to 0. Therefore, this h dash of c equals to 0, then you will get f dash of c minus f of b minus f of a by b minus a. Why? Because here h dash of c equals to 0. Therefore, this minus value comes to this side, it should be positive. It should be positive. Therefore, here, according to Rolle's theorem, we can write this should be positive. It should be positive. Therefore, finally, we will get this minus value comes to this side positive. Therefore, f dash of c equals to f of b minus f of a by b minus a. Here, this minus is belongs to, this is the bracket is here. Don't confuse about that. This is. Therefore, according to the Lagrange's theorem, there exists C belongs to open interval a comma b such that f dash of c equals to f of b minus f of a by b minus a. This is the Rolle's theorem. So here this is the very important Rolle's theorem. Yeah. Okay. First, before going to discuss the problems, what is the use of the Lagrange's theorem? So Lagrange's theorem means, I will write the only conclusion of the Lagrange's theorem. There exists C belongs to open interval a comma b. There exists C belongs to open interval a comma b such that f dash of c equals to f of b minus f of a by b minus a. This is the Lagrange's mean value theorem. What this meaning means, here the rate of change in the function f according to x, which is equals to the rate of change of f at a point c. Once again, I am telling you, this is also called average. This is also called average. The average of a function, the rate of change or average of a function is equals to rate of change of the function f at c. Here f of b minus f of a by b minus a is called the average of a function f on the interval a comma b. This average equals to rate of change f dash, rate of change of f at c. Rate of change means derivative of f at c. This is the geometrical interpretation of the Lagrange's mean value theorem. Now come to the solve the sum of the problems. Write some example. Example 1. What is the example here? What is the example here? Find the value of c. Find the value of c. Find the value of c of Lagrange's mean value theorem. Of Lagrange's mean value theorem when the function f of x equals to 2x square plus 3x plus 4 in the closed interval 1 comma 2. This is the given function. Now we have to simplify this problem. Okay. See, suppose for example solution. In the solution, first take the given function. What is the given function? Given function f of x equals to 2x square plus 3x plus 4, and the given interval closed interval 1 comma 2. Now we have to apply the Lagrange's mean value theorem here. But already you can see f of x equals to 2x square plus 3x plus 4. This is the one of the polynomial function. Okay, it is always differentiable and also continuous, not only the given interval 1, 2. If we take any interval, on the interval, this function is continuous. Therefore, first we have to write the conclusion. F is continuous on closed interval 1, 2. And the point number 2, F is differentiable. F is differentiable on open interval 1, 2. These two are true, always true. Why? Because this is the polynomial function. Every polynomial function is differentiable and also continuous. Otherwise, we can check it. F dash. What is the derivative of f dash? X square derivative is 2x square. 2 is the constant. X square derivative is 2x plus 3 is the constant. X derivative is 1 plus 4 differentiation is 0. Therefore, f dash of x is exist. This f dash of x value equals to 4x plus 3. Therefore, f is differentiable. And also, every differentiable function is continuous. Therefore, f is differentiable. That value is equals to 4x plus 3. One more condition. Every differentiable function is continuous. Therefore, f is continuous. Therefore, this is the conclusion of these 2 points. First one, why it is continuous, why it is differentiable. I clearly explained here. You can see. So, if it satisfies the 2 conditions by the Lagrange's mean value theorem, so it satisfies the Lagrange's mean value theorem. Lagrange's mean value theorem. There exists C belongs to open interval a comma b. A comma b means here 1, 2. There exists C belongs to open interval. Here I written closed interval, but it is open interval. There exists C belongs to open interval 1, 2 such that what is the formula? F dash of C equals to f of b minus f of a by b minus a. This is the by the Lagrange's mean value theorem. There exists C belongs to open interval a comma b. Here a comma b means 1, 2 such that this one. That means here this is can be written as f of 2 minus f of 1 by 2 minus 1. That means here already you know, first we have to find f dash of C. Already you calculated f dash here. First we have to find all the values. F dash of C. F dash of C means already you calculated here f dash 4 into C plus 3, that equals to 4C plus 3. Now we require f of 2. F of 2. F of 2 means f of x already you know, 2 into 2 square plus 3 into 2 plus 4. That equals to 2 2s are 4, 4 2s are 8 plus 2, 3 2s are 6 plus 4. That equals to 18. Now come to the next point. Next we require f of 1. F of 1 means 2 into 2x square. 2x square means 2 into 1 square plus 3 into 1 plus 4. That equals to 2 plus 3 plus 4. That equals to 9. Here we calculated f dash and f of 2 and f of 1. Substitute these are all the values in the equation 1. All of you clearly understand equation 1. F of C equals to f of b minus f of a by b minus a. That means f of 2 minus f of 1 by 2 minus 1. So f dash of C. Here f dash of C means write the value. F dash of C means already you calculated 4C plus 3. 4C plus 3. See here from 1. What is 1? F of C. F of C means 4C plus 3. This is f of C equals to f dash of C. F dash of C means 4C plus 3 equals to f of 2 minus f of 1. F of 2 means 18 minus 9 by 2 minus 1. 18 minus 9 by 2 minus 1. 18 minus 9 by 2 minus 1. That means 4C plus 3 equals to 18 minus 9 means 9. Am I right? By 1. That's simply 9. Therefore, 4C equals to 9 minus 3. Therefore, 4C equals to 6. C equals to 6 by 4, that equals to 3 by 2. 3 by 2. 3 by 2 means 1.5. So what is the given interval? Given interval is 1 comma 2. Therefore, this 1.5 C means 1.5, which should be belongs to 1 comma 2. That means here this 1.5 should be between 1 and 2. So this is called the Lagrange. Therefore, it satisfies. Therefore, the given function satisfies the Lagrange's theorem. Therefore, the given function satisfies Lagrange's mean value theorem. That means here what we find here, that value should be here, which the C value must be belongs to between 1 and 2. This is called the Lagrange's mean value theorem. Okay.